Today we're going to cover special right triangles. And when we talk about special right triangles, first we're talking about one that you worked with in geometry, the 30, 60, 90 right triangle. This is going to be very easy, and it's just going to be a quick review, but it is very important in terms of trigonometry, as you're going to find out. If I have a 30, 60, 90, the side opposite the 30-degree angle is 1. Now, if that is true, then the hypotenuse is 2, or in other words, 2 times the shorter leg. All right, the other way that you can think of this is this one is 2 times the shorter leg. Okay, twice as long. All right, and then the side opposite the 60-degree angle is radical 3. Or we could think radical 3 times the shorter leg. Radical 3 times the shorter leg. Okay? So, what's going to happen tonight is you're going to be asked to find the missing sides. And you're going to be given a triangle, and it's going to be a 30, 60, 90. Hopefully it'll be drawn better than that one I just drew. And they're going to label the sides, and they're going to say, you know, this side is C, this side is D, and this side is F. And they're going to give you some information. How about this? If F equals 8, find C and D. All right, a lot of this is going to be easy, but let me just walk through it with you. So if F is 8, that means the hypotenuse is 8, right? Now, didn't we say that the hypotenuse is 2 times the shorter leg? So what's the shorter leg then? 4. This is going to be 4, right? And what is the longer leg going to be? 4 times radical 3. So somewhere over here we can just kind of label that C is 4 and D is 4 radical 3. All right? Now I'm not going to redraw the triangle. I'm just going to relabel it because we're going to do another one. There are other situations. How about if they tell you that C is 3 and find the other two. Find D and F. So this time we start with C and we say that it's 3. And then we just work around. So the longer leg is going to be 6. I mean, the hypotenuse is going to be 6, right? And then the longer leg is going to be 3 times radical 3. That was easy. So F was 6, and D was 3 times radical 3. Now, where you have to pay attention is on this third example. What if they tell you that D is 7? Let me erase my other numbers here. So now they're telling me that this side is 7. So we're working backwards a little bit. So here's how you have to approach this. You have to use this little piece of information right here. That the longer leg, and I want you to actually write this down. The longer leg is equal to the shorter leg, which I'm just going to put SL, times radical 3. The longer leg is equal to the shorter leg times radical 3. Well, in this case, they gave me the longer leg. So let's put that in here. The longer leg, 7, is equal to the shorter leg. Let's call that a letter. How about n times radical 3? And so if you want to find the shorter leg, then you've got to solve for n. So I would divide both sides by radical 3. And I'd find out that n is 7 over radical 3. But we don't like leaving radicals in the denominator, so we're going to rationalize this thing. I'm going to multiply the top and bottom by radical 3, and the final answer for the shorter leg is 7 radical 3 over 3. The shorter leg is 7 radical 3 over 3. Now, how do I get the hypotenuse? 2 times that. Okay? So if I want to get the hypotenuse, it's going to be 2 times 7 radical 3 over 3. Well, we've got to remember what we know about fractions. If I multiply a fraction by a whole number, put the whole number over 1, the hypotenuse is going to be 14 radical 3 over 3. All right? So sometimes you have to work backward, and this statement right here is critical to getting that done correctly. All right, now let's talk about the other special right triangle. Actually, there are more than 2, but we're just going to work with these 2 today. And that is the 45, 45, 90 right triangle. Well, this is also an isosceles triangle, all right? And so if this side is 1, this side is 1. And the part that we remember is that the hypotenuse is always the leg times radical 2. The leg times radical 2. All right? So, just like before, they're going to give you a 45, 45, 90. They're going to label the sides. How about A, B, and C? And they're going to give you information. They're going to say, okay, A is 3. What are the other 2 sides? Well, B is going to be the same thing, right? Because that's one of the legs. And then the hypotenuse is going to be the leg times radical 2. So C is 3 times radical 2. Easy enough? Now, why don't we go right to one where we have to work backwards again? What if they tell you that C is 11? Okay, they tell you that the hypotenuse is 11. Well, once again, we want to start with that kind of magical statement that says the hypotenuse is equal to the leg times radical 2. So if you have a simple equation like that, then you can plug in what I know. I know the hypotenuse. The hypotenuse is 11. Okay, we were given that. So I put 11 where the hypotenuse is equal to the leg times radical 2. I'll put an n there. N times radical 2, and then solve. So you're going to divide both sides by radical 2, and then rationalize, and you're done. 11 radical 2 over 2 would be both legs, right? This would be both A and B. And we're going to stop there for today.